Do you have a really cool idea or project that you want to start to work on and see where it leads? Well, you have come to the right place. In these videos, I will go through setting up and implement the backend side for your killer app. My name is Johan and I'm an electrical engineer. I have been working with both Linux and embedded systems for over 5 years now. If you want to see more of my work, go to my GitHub page, and if you want to know more about me, go to my homepage. Perhaps you want to build a mobile or desktop app and want to be able to communicate with a backend, whether it's a chat application, the new Instagram, or something else. If the frontend is able to communicate with a backend service, it opens up much more functionality and flexibility that could be enabled for the end user. It also enables you to get log and crash information if the application misbehaves in some way. These videos will mostly focus on the backend or the cloud solution for the application, including software development and communication between backend and the frontend. This is a helicopter view of a solution where you have a backend and a frontend part. The frontend could be a homepage, mobile or desktop app. The information might then get serialized into a database and communicate internally with a message broker to other recipients. It depends on how the information should be passed around in the backend and what we want to optimize the backend for. We will dive deeper into these topics in later episodes when we discuss and plan for the internal workings of the backend. Because we are mainly focusing on the backend part of the solution, it's a good idea to start building the foundation for it. Whether you will use microservices or a monolith, we need to have some hardware which can run the backend. If you have a Raspberry Pi lying around, that would be great. I have one lying around which I will use for this project. Another single board computer, or SBC in short, a PC or a server would also work for this project, as long as you can install Linux on the hardware. But the Raspberry Pi is small, energy efficient, and has sufficient hardware resources to be a backend server for this project. If we need more hardware resources later on, it's quite easy to move the solution to another hardware, as long as it is the same operating system. So let's start to install the Raspberry Pi OS. Head over to your favorite search engine and write Raspberry Pi OS. I will provide a link down below and I will choose Raspberry Pi OS, raspberrypi.com/software. I will install the Raspberry Pi imager, which I will use to install the operating system on the SD card. I will choose download for Windows and click on the newly downloaded executable file. I will choose to install the Raspberry Pi imager and also launch the Raspberry Pi imager. Choose OS. I will choose I want a 64 based operating system. I will choose Raspberry Pi OS Other and choose Raspberry Pi OS Lite 64-bit. And I will take my SD card and put it into my SD card reader, something like this. And I will choose storage and choose my SD card here. Let's see what happens if I press the cogwheel here. I want to enable SSH and set username and password Pi and my password. Here we can configure wireless LAN as well, so I will choose that. and hopefully this is my password that I have for my SSID here. I haven't tried this before. Wireless LAN country is Sweden, so SE is Sweden. Time zone Europe, Stockholm. Keyboard layout is SE, is Swedish keyboard layout, so I will choose that. Alright, so telemetry is that it can send the data back to the Raspberry Pi Foundation for logs. Eject media when finished, sounds good. Play sound when finished, I don't need that, I think. Okay, I will hit save and press right. Yes, I'm sure that everything will be erased, so I will press yes here as well. First time we're starting up, we are generating SSH key and extending the hard drive, and then we are going to reboot. Alright, so the system has booted up. I will log in with my username Pi and my password. I will also write IP address to see that I have an IP address from my DHCP server, and I will also ping 8.8.8.8, which is a Google DNS server. Everything seems to be working here. Let's head over to the PC and try to remote log in to the newly installed backend. Alright, so everything looks good and we know the IP address of the Raspberry Pi server or the backend. I will start Putty by pressing the Windows logo and write Putty and SSH to the backend server, which is 10.10.10.122. I will trust the key and choose yes here. Log in as Pi and my password. Cool. So I will try to ping 8.8.8.8, which is Google DNS server, and it looks good. So let's update the backend server as well. So I will write sudo apt update and hit enter, and write sudo apt upgrade -y or -y, hit enter, and y parameter says yes. I will automatically answer yes on the question if I want to install the updates. Alright, so we have upgraded the Raspberry Pi operating system to the latest version, and just reboot it then. Sudo reboot for reboot of the server or backend. Just hit enter. And we need to wait for a couple of minutes to see if we can access it again. Okay, let's see if we can access the Raspberry Pi server or the backend. So I will just click the Putty icon here and use restart session here. Log in as Pi and my password. Our backend server is now up and running, and we can start to discuss, plan and implement how the backend and frontend should be able to communicate with each other, and also the internal workings of the backend. I plan to do multiple backend solutions because I want these videos to be guides to set up different types of backends. Please give me feedback on what you are interested in the comments down below, and we will discuss it further there. Until then, have a nice day and see you in the next video.